Hello, I'm John Helmly. I'm a licensed professional counselor with Family Counseling Service here in Athens. And while I'm not a neurologist or a neuroscientist, I do share a common fascination with Oliver Sacks. That is the fascination with the human brain and nervous system and the roles that these play in the way we interact with each other, the way we interact with ourselves, and mental illness in general, particularly as this relates to emotion regulation issues and things like that. Human beings are biopsychosocial creatures, and as a counselor, I have to pay attention to all three of those domains when conceptualizing cases or treating clients. This talk merely scratches the surface of the very broad topic known as neuroscience, which is part of that biological domain. Specifically, I'd like to talk with you today about a theory of the autonomic nervous system known as Polyvagal Theory. I want to give you a basic overview of the theory, but also want to offer some possible applications to Oliver Sacks' life and career. If you'd like to learn more about Polyvagal Theory, I suggest that you just go to YouTube and look up Stephen Porges, who is the founder of Polyvagal Theory, and watch some of his videos as he talks about the theory, and then possibly look up Deb Dana, who has taken the theory and applied it to therapy and come up with all kinds of really cool therapeutic approaches to help guys like me help my clients. But I just suggest you start with looking up and watching some YouTube videos. If you want to go further after that, there's several really good books you can pick up, both by Stephen Porges and Deb Dana and others as well. So let me begin this talk about the autonomic nervous system. If you recall, when you were in possibly in high school, maybe first year college, you took a biology class and you learned about the autonomic nervous system, and you learned that it had two branches, and that was the sympathetic branch and the parasympathetic branch. The sympathetic branch was also referred to as the fight or flight branch, and then the parasympathetic was the rest or digest branch. And both of those together help to regulate all these involuntary functions of the body. Autonomic simply means automatic, or you might say involuntary. So these actually are nerves that go down and connect to various organs and help to regulate those organs. You know, if we didn't have this autonomic nervous system working for us, we'd have to remember to breathe. You know, we could never go to sleep. Breathing is a very important function that is regulated by the autonomic nervous system. Also, heart rate, blood pressure, digestion, things like that are all regulated by the autonomic nervous system. And polyvagal theory has expanded that original thinking on what the autonomic nervous system is. I wanted to offer you, before I get into like the biological piece of it, I wanted to offer a definition given by Deb Dana of what polyvagal theory is. I should say a description rather than a definition. And I'm just going to read this to you. It says, polyvagal theory provides an updated map of the autonomic nervous system, defining how this system shapes experiences of safety and impacts the ability for connection. Polyvagal theory gives therapists a way to bring the autonomic nervous system directly into therapy and helps clients become active operators of their own nervous systems. The stories clients tell themselves about who they are and how the world works begin in the autonomic nervous system. Information is sent through autonomic pathways from the body to the brain, where it is translated into beliefs that shape daily living. The brain takes the autonomic information and creates a story to make sense of what is happening in the body. If you want to change the story, start by changing the state. So basically what's going on is, you know, our bodies are feeling a certain way, they get into a certain autonomic state, and then us being meaning-making creatures, we want to make sense of it, so we create a story to go along with the way our body feels. Now, of course, it can go the other direction as well. The mind can come up with things and create stories, and then the body responds to that as well, so it goes both directions. As far as the biological components of the of polyvagal theory, or the autonomic nervous system according to polyvagal theory, is that there are three branches, not just two. Or you might say that one of the two branches has been discovered to be two additional branches. So you still have the sympathetic nervous system branch, but you also have, as part of that parasympathetic, one that is known as the dorsal vagal complex, and one that's known as the ventral vagal complex. Now, the dorsal vagal complex, first of all, that's part of this nerve known as the vagus nerve, hence the name polyvagal. The nerve goes from it's also known as the 10th cranial nerve, and it goes down from the brainstem and goes down and connects to everything below the diaphragm, all the major organs, like things that control digestion and reproduction and such. That would be your dorsal vagal complex. The other branch of that vagus nerve goes down and connects to the heart, connects to the lungs. So we say everything above the diaphragm is regulated by the ventral vagal complex. In fact, if we set this up as a hierarchy, we would say that the ventral vagal complex is the overseer of the entire autonomic nervous system. In terms of breathing, it's very important that the sympathetic nervous system, whenever we breathe in, we release a tiny bit of adrenaline. Whenever we breathe out, we release a tiny bit of acetylcholine. These two chemicals together keep our heart rate lower and also variable, which keeps our system regulated. The brain interprets a lower variable heart rate as all safe. A lot of this in polyvagal theory has to do with safety. There's a concept in polyvagal theory known as neuroception. Now, this is the body's built-in surveillance system. So it's your autonomic nervous system is reading the environment. Now, this is a non-conscious process. It's not in your awareness that it's happening, which is essential, because if you're in a real serious life threat situation or even a really dangerous situation, a lot of times you really don't have time to think your way out of it. In fact, when this system kicks into action, there's an impairment to part of the brain, and it's actually the part of the brain that makes us human. It's this prefrontal part of the brain that controls things like impulse control and rational thinking and reasoning skills and those kind of things. So we're rendered on the same level at that point as all the rest of the animals, essentially. And depending on our personality, we might react in like a bear or a lion or a squirrel or a deer or something like that, based on that impairment. But the reason why it's doing that is because it's reallocating resources to get more blood flow to major muscle groups like your thigh muscles, and get more oxygen to the lungs and things like that gets you ready for fighting or for fleeing. Now, that's the sympathetic nervous system, and that's that fight or flight response. And as I said, it's very adaptive. The neuroception is what allows us to read that threat level in the environment. And then there's these other two branches. The dorsal vagal complex that goes down and regulates digestion and all is also known as the freeze response branch, because it actually releases chemicals that cause us to freeze. Now, this is the oldest part of this nervous system. In fact, it dates back to around 500 million years ago. It's still the reptilian response to danger. And even some mammals, of course, the possum is notorious for this freeze response. The old saying, play dead like a possum. So many of us have seen this and know this. And then there's this ventral vagal complex, which is the one that really is is one that that's the good place, I guess I would say. It's this been referred to as the Goldilocks zone, where things are just right. When that branch is acting the way it's supposed to, and the whole system is being regulated properly, then we feel safe in the world. We feel like people can be trusted. We feel like the world is a trustworthy place to live. It's a safe place to live. This has also been referred to as the social engagement system. This particular branch, actually, that nerve, not only does it attach to the heart and the lungs, but it also goes up into your facial muscles, and it goes and connects around the eyes, and it goes and connects to the middle ear muscles. So it allows us to, respond based on auditory signals that we might hear in our environment, such as the low growl of a predator or the high shrill of a prey, and helps us to automatically start moving away from that. And then the parts that go and attach to the eyes allow us to read other faces and facial expressions to determine if it's friend or foe, and the energy that others are putting off. That neuroception is this idea that we can read the environment without even having to be aware. So we're picking up on all kinds of cues that other people their nervous systems are putting out. Their autonomic energy is released out towards us and ours towards them. Now, there's another concept in polyvagal theory known as co-regulation. Co-regulation is this sort of regulating to someone else's autonomic energy. If you think about emotional support animals and why they work, how they help people to calm down, they're known to lower blood pressure and things like that. The reason why is because of this co-regulation and this neuroception that's going on between us and the animal. The animal is putting off this very ventral vagal, very calm social engagement energy, which allows us to read that, and then it just automatically lowers our blood pressure and our heart rate, and increases heart rate variability, which is very healthy and necessary for proper functioning. So this is the basic system, and it's sort of and always this sort of tug of war between protection and connection. So if we're afraid, if there's danger, or if we sense that there's danger, as with trauma, one of the sad things about trauma is it sort of hijacks that system, and our neuroception doesn't work the way that it's designed to work. So we don't co-regulate well and that kind of thing. So our system might read danger sometimes where there actually really is no danger in the environment, or very minimal, certainly not life threat level, but we might have something known as a panic attack or something like that, which is a really blown out sympathetic nervous system response, fight or flight type response. So we don't want to be having those kind of responses, or even have an anxiety disorder, because our nervous system is set up as sort of hypervigilant and always releasing those types of chemicals. Adrenaline and cortisol are the two chemicals that are released by the sympathetic nervous system. Of course, adrenaline gets you going, and we do need a little bit of that in a normal functioning system. As it relates to our breathing, as I say, there's part of that is necessary. When we breathe in, we release a little bit of adrenaline. When we breathe out, we release a little bit of acetylcholine. Those two together keep our heart rate down and variable, which, as I said, is essential for proper functioning of the nervous system. Problems you run into are where that system's sort of been hijacked, or even if you were living in a very stressful time like what we're living in right now with this pandemic. It's very stressful for people. There's a lot of unknown, and people are set up with this hypervigilance almost, where there's a lot of sympathetic nervous system activity. So we're constantly releasing adrenaline and cortisol into our systems. And it's very hard when that's happening for us to want to connect with other people. And then it's further complicated by the forced isolation that takes place as a result of this pandemic. We know that social connection is absolutely essential. So we have to find ways to do that, whether it's reaching out to other people over the phone or video chatting or whatever it is. But we do have to have that as part of that. But whenever our sympathetic nervous system is overactive, this social engagement system is not. Now, I want to talk a little more about the social engagement system because it's really important. The social engagement system, that ventral vagal complex, I already mentioned one chemical, acetylcholine, that helps in heart rate variability and heart rate in general and all. But there's another chemical that's released from that. It's called oxytocin, which most people have heard about. It's also known as the love chemical, and it's the thing that causes us to feel like we want to connect with other people. But if that's not working the way it's supposed to, then we're not wanting to connect with other people. We're wanting to isolate. We're in protection mode, not connection mode. So you can see the dilemma that exists in that. Okay, now I'd like to just wrap up by offering a couple of possible applications to Oliver Sacks' life and his career. One of the things he talks about in the movie is where is home. He said, he didn't really have a good sense of where home was, so he sort of had this mental home. And I imagine his mental home probably had a lot of ventral vagal activity where, he imagined it as a peaceful place. But, his life was this tug of war, really, between survival, this fear of revealing his authentic self, and especially as it relates to his sexuality, and this fear that he would be, even in like in London at the time, it mentions in the film that there was potential for chemical castration, and certainly shunned upon homosexuality in that time period. Wow, have we come a long ways with these things? But so he was in constant fear of that, so much so that he intentionally isolated a lot of times. So there's this battle going on all the time within him, and I would say his autonomic nervous system was probably volatile. There was probably a lot of ups and downs with it based on that. I also wanted to mention the part about the catatonia and the patients that he worked with that, he ended up writing the book, The Awakenings, and also the Robin Williams movie that came out afterwards. The work that he did with the catatonic patients with the L-DOPA that sort of brought them back to life and everything. And it fascinates me, and I've thought about this a number of times in the past I wonder if catatonia is some kind of a malfunction with that freeze system, with that dorsal vagal complex, and I wonder where that's going to lead ultimately some of the research and the things that will come out ultimately. I want to tell you about a couple of good things before I wrap up that have come out of this. There's a new music system. It's an app for your phone that some therapists have, and I'm really seriously considering this. It's called Safe and Sound Protocol, and it's actually an app that plays music that's been run through this algorithm that the frequencies have been changed in order to stimulate that ventral vagal nerve, the vagus nerve, at the ears, those middle ear muscles, and help to regulate that system and get more ventral vagal activity, so a person feels safer. But there's all kinds of other things you can do to activate the vagus nerve or to stimulate that vagus nerve. There's tons of great research coming out on this. And I want to show you one last thing about breathing that you can manipulate that system. As I said earlier, when we breathe in, we activate the sympathetic nervous system and we release a tiny bit of adrenaline. When we breathe out, we release a tiny bit of acetylcholine. Now, knowing that the exhale is what releases the acetylcholine, and that's the calming chemical that sort of applies the brake to that sympathetic energy and allows your heart rate to slow down, which the brain interprets as all safe, then we should manipulate the system to do that. And the way we do that is a breathing technique that I call extended exhale breathing. So you just have to remember to breathe out 3 to 5 times longer than you breathe in. And I breathe in through my nose. and out through my mouth. And I try to extend that exhale as long as I possibly can, because I know what's happening inside my body is I'm releasing more acetylcholine, and that's going to lower my heart rate, which is going to calm me down, and my brain's going to think that I'm safe and I'm going to want to engage with other people. So that's all I have today, and I hope you really enjoy the movie.